Though not all of Vermont is mountainous, a good bit of it is, particularly in southern Vermont. And even in these mountains, there is quite the desire to still access the areas contained within them. The places that the major roads are built in these mountains are along the valleys, next to rivers and streams. One reason to build in the valleys is that most roads in Vermont have just been a continuous chain of improvements since the first settlers made their way into the area. These valleys were the easiest for them to move along. Since valleys generally have the flattest and most fertile land, they're also where most people settled, thus making them the areas that need to be connected by roads. Granville Gulf, which shares Route 100 in Alder Meadow Brook, headwaters of the White River, is particularly narrow. It's actually the narrowest road-river-valley combination I've seen anywhere in Vermont. An important thing to remember with these narrow valleys is that before the road was built, the river or stream had the entire width of the valley to wander back and forth on and dissipate its energy. And yes, there has been some cutting of the valley to make it a bit wider for the road, but for the most part, when the road was installed, it just goes into the area that the river would have been in before the road is built. While currently at the low summer base flow water level, it does not seem like the stream has any issue flowing in its current channel. But if there's a large storm that comes along, this channel can fill up really quite fast with the water coming off the mountains. As we are in the high reaches of the watershed, that means that the water that does flow through here, even though the total volume will be a lot less than lower down, it will come at a much faster rate. When limiting the stream to just the area where the road is not, what's really happening is that you're increasing the effective grade of the channel. While the point to point, like end distance as the crows fly distance, is the same between the upper side of the valley and the lower side of the valley, the stream center line distance decreases when you straighten the channel, such as would have occurred here, at least partly. That is because you're taking out any meanders that were occurring, and so the stream has a shorter distance to travel, thus increasing the centerline grade, which is what is really important when considering how the stream flow is going through. This increase in grade, along with the depth of the water that occurs during floods, means that the water will pick up speed beyond what it had in the original channel, and with more speed comes more erosive potential. As can be seen, in some places in this valley, the road takes up approximately 2/3 of this valley floor. That means the stream is limited to a much narrower and straighter channel than it would have had before when it originally eroded this channel the full width of the valley floor. In a high water event, though the floodwaters may come over the banks of the low water channel, the importance of a sinuous channel is still there. The boundary friction factor of the area outside the channel is typically higher due to the trees and shrubs than the area in the channel. This higher friction factor helps absorb the energy of the water, slowing it down. Related is that when channels are narrower in cross-section, the same area of water rises higher. When the water is in a wider channel, at a lower level, the hydraulic radius is smaller, which means it has more contact area with the drag-generating surface of the channel banks relative to the cross-sectional area. Again, providing greater opportunity for removing energy from the water. Natural streams are typically shallower and rougher than this example, which magnifies the effect more. A more typical mountain valley is seen in Ripton, Vermont, shared by Route 125 and the Middlebury River, which then drains into Otter Creek. In this valley, the road does not take up as much of a percentage of the valley floor and is higher above the stream bed. However, a section of this road has washed out approximately once every 10 years. The traditional method of fixing a washout is to fill the area with aggregate and slope it down at a 2-to-1 slope down to the river, including armoring. A newer method is seen behind me. This technique is stacking rocks. It takes more effort to install, but has several advantages. One of those is that because of the rocks as they are formed together are able to stabilize the soil more, the 2-to-1 slope isn't necessary. So a steeper slope can be used, providing more of an area for the river to use in the valley, increasing energy dissipation, which is important. Additionally, as generally the rocks used in this stacking rocks technique are larger than would otherwise be used, they can better resist erosion. Not seen at that location is another method of improving streams, covering the installed rocks with grubbings and seeding. This is to reduce the heating of the ground by the sun so that the water in the river stays cooler. This advance in embankment protection, along with other techniques, ideally will make Vermont's roads more resilient to washouts. Washouts of the type seen over a large scale of southern Vermont during flooding caused by Tropical Storm Irene in 2011, as well as many other more localized, smaller scale flooding we see on almost a yearly basis.